In this video, we're going to look at problem solving and applications of linear equations. All right, problem solving and applications of linear equations. Let's first talk about problem solving. Of course, now that we know how to solve equations, we want to be able to use equations to actually help us solve problems. And this is where problem solving comes into play. Can be a little bit complicated, but as long as you are grounded in solving your equations and you understand the vocabulary of the mathematics that can be read into a problem, then you will be okay with problem solving. I do have some steps here that we want to use when we're going to be problem solving. And some of these might be common sense, but we will go over them. The first step, which is probably the one that's common sense, is to read the problem. Of course, we can't solve a problem without knowing what details we have inside of that problem. So we need to read the problem and understand it, pick out the relevant information so that we can use that information to solve the problem. After we read the problem, we're going to assign a variable, right? So something's going to be unknown, or we're going to have to solve for something. And so we're going to assign our variable. We're going to create an equation, right? Because we want to solve it. After we create it and solve it, we're going to make sure that the solution actually makes sense. Let's look at an example. First type of example is an unknown number problem. All right. It says that 14 less than 5 times a number is 121. And we want to find the number. Okay. Well, first thing I always do is I reread the problem and make sure I know my information. All right. 14 less than 5 times a number is 121. All right. We want to be able to find the number. Well, what we're going to do first is we're going to assign our variable. I'm going to let my variable x be the number. Okay. And now what I want to do is, using the words that I'm given verbally in this problem, translate it to an actual algebraic expression. So we're going from the verbal to the algebraic representation, right? 14 less than 5 times the number is 121, all right? Well, I know that my number is now x, so I'm going to reread it with x right there. 14 less than 5 times x is 121. That gives me, if I take 5 times x, and if I want 14 less than that, I have to subtract 14 from it, and that has to be equal to 121. And that's our equation. So we've read the problem, assigned a variable, set up the equation. Now let's solve the equation, right? Since that's a minus 14, we're going to have to add 14 to both sides. So we'll get 5x, the 14's cancel, equals 135. And last but not least, we can divide both sides by 5. 135 divided by 5 is 27. So I have x equals 27. All right, to make sure that this is actually true, I'm going to put in my calculator, I'm going to do 5 times 27, and I'm going to subtract 14 from it and make sure that that equals that 121, right? And that's one of the good ways to check yourself. And that is in fact true, and so our answer would be 27. That's our number. All right. Now we're going to look at another example. In this example, it's a geometry problem. And geometry is all about the shapes, sizes of different figures in the world. All right. It says the length of a rectangle is 7 inches less than twice its width. All right. If the perimeter of the rectangle is 64 inches, find the dimensions of the rectangle. All right. Keyword in this, there's a lot of keywords, right? We have length. We have width, we have perimeter, of course rectangle is one of the main keywords, and dimensions, right? What it means by dimensions is the sides, what makes up the actual sides, and that's the length and the width. The thing that relates all of this stuff together is perimeter, right? If I have a rectangle, perimeter is the measure of the length of the outside of a figure. So for a rectangle, we have the formula that the perimeter, P, equals 2L, where L is my length, plus 2W, all right, where W is my width. And so what I want to be able to do is read this problem and create the equation actually from this formula here. But when I have these linear equations, they can only have one variable. And so I'm going to have to be able to fill in stuff for P, L, and W where I will only have one variable. All right. So I'm going to come off to the side over here. I'm going to put P, L, and W. And I want to come up with something for each of those things. All right. I'm going to reread the problem. It says the length of a rectangle is 7 inches less than twice its width. If you notice, they're telling you your length as if you know the width, but you don't know the width. So that's what your variable is going to be. I'm going to let width stay my width, right? And so I'm going to keep W as W, and it stands for width. Okay. Now that I know my width, it says that the length of the rectangle is 7 inches less than twice. So length is, there's my equal sign, 7 inches less than twice the width, which is W. All right. So if I take twice my width and subtract 7, that'll give me 7 inches less than twice the width. All right. It says if the perimeter of the rectangle is 64 inches, well, they explicitly give me that P is 64. I want to find the dimensions. And so what I'm going to do is I'm going to substitute these things in, keeping in mind that my variable W, well, W is my variable for width. So I get 64 equals 2. Now, this is my L right here. Instead of using L, I'm going to write 2W minus 7 plus this 2W that's sitting out here. And now I have an equation that I can solve for W, right? I'm going to distribute my 2. That'll give me 4W minus 14 plus 2W, right? I can combine my 4W with my 2W. That'll give me 6W minus 14, right? I can add 14 to both sides. That'll give me 78 equals 6W. And if I divide both sides by 6, that'll give me W equals 13. So my width is 13 inches, all right? So my width, 13, and my units is inches. Now I need to find my length. Well, my length is equal to 2W minus 7, which I have right here. And so to find my length, since I already know that W equals 13, I'm going to have 2 times 13 minus 7. That's 26 minus 7, which is 19. So my length is 19 inches. All right. So that's a good example of really going from a verbal representation of mathematics to an algebraic representation. Let's look at another example. This example includes what we call a consecutive integer problem. And what I mean by consecutive integer, I mean integers that are right next to each other. All right. For instance, the next consecutive integer after 1 is 2. Next one after 2 is 3. All right, so on and so forth. In this problem, it says the sum of 3 consecutive odd integers is 237. Remember, your odd integers are your integers that end with 1, 3, 5, 7, 9. All right, and so since I don't know any of those integers, I'm just going to let x, all right, my first integer, I'm going to abbreviate integer with int, be represented by x. All right. But I know I'm going to have a second odd integer, and I'm going to have a third odd integer. All right. And all of these are odd, even though I'm not writing it here. All right. Well, if I look at odd integers, like 1, 3, 5, those are consecutive odd integers. They're actually 2 units apart. For instance, if I add 2 to 1, I get to 3. If I add 2 to 3, I get to 5. So if my first integer is represented by x, then my second integer is going to be represented by x plus 2. And then my third integer is going to be represented by x plus 2 plus 2. But of course, we don't have to write all that plus 2. That'll be the same as just saying x plus 4. Okay? And so when I see the fact that it says that the sum of my three consecutive odd integers is 237, well, since I know all of my odd integers, right, x plus 2 plus x plus 4, if I add those together, it's going to equal 237. And so I'm going to solve this by combining my x's together. That'll give me 3x. And if I combine my 4 and my 2, I get 6. And that's going to equal 237. Of course, I can subtract 6 from both sides. I'll get that 3x equals 231. And once I do that, I'm going to divide both sides by 3. And I'll get x equals 77. So my first consecutive integer is 77. My second, well, 77 plus 2 is 79. And then 77 plus 4 is 81. And so those are my 3 consecutive odd integers. And notice that they are all odd. Same concept will work if it said even integers. Let's look at one more example. And this type of example is called, I'm going to be a little bit more specific. I'm going to call it uniform motion problems. So if someone is, traveling on a trip, we're going to assume that they're going the same exact speed the entire way, no slowing down, no speeding up. And if that is the case, then their distance and their rate and their time is related by this formula here. Distance equals rate times time. And normally we'll use d equals r times t. Okay, so what happen in these types of problems, the most basic ones, is that I'll give you either the distance and the time, or the rate and the time, or the distance and the rate, and I'll ask you to find the other variable that is missing. Let's look at this example here. It says Marissa drove 344 miles in 5.75 hours. What was Marissa's rate for the trip? Okay. Now, rate is the same thing as your speed. Distance is, distance, the length that you're traveling. And the time is how long it takes, right? And so when it says Marissa drove 345 miles, that is your distance. So instead of writing D, I'm going to write 345. And it takes her 5.75 hours. So I'm going to have R times 5.75. And of course, if you wanted to, you can write the 5.75 first and the R second. The question asks, what was Marissa's rate for the trip? Well, we want to solve for R. Since that's a multiplication between R and 5.75, we're going to divide both sides by 5.75. And if you get your calculator, you can do 345 divided by 5.75, and you will see that you'll get that the R's cancel there, but R equals 60. And your units are going to be 60 miles per hour. That's how fast she was going. All right, and this concludes our video on applications of linear equations.